4.1 radians. So far, we've been using degrees as our unit of measurement for angles. There's another way of measuring angles. It's often more convenient, and the idea is simple. We're going to associate a central angle. Keep in mind the central angle is, for example, here. And we're going to associate that angle with an arc that it intercepts. So a 90-degree angle would intercept this part of the circle, right? And so the arc is the distance on the outside of the circle. We know that the circumference, we know that the circumference of a circle is 2 pi times r. So if I want to know what the arc AB is, so what's the distance from A to B on the outside of the circle, I would need to take the circumference and say, well, I need to take 90 out of 360, which is actually 1/4 of that circumference, and 1/4 that times this would be pi over 2 times r. If I do this with an angle of 180 degrees, 180 is exactly half, right? So I would take half of a full circumference. Well, that would then be pi times r. And here it's all of the circumference, so it would be 2 pi times r. So here is your connection. What we're going to do is we're going to define our angle of rotation. We're going to define it as the number of radii it intercepts on the outside of the circle. That's the okay, and that is our definition of radian degrees. So radians refer to the distance intercepted on the outside. So a central angle that intercepts an arc on the circle equal in length to the radius of the circle has a measure of 1 radian. So what does that look like? So let's draw a circle. So there's a circle, and the radius would be, that would be about the center. And then if I measure that distance, and if I take that radius and I measure it along the outside of the circle here, I measure that distance on the outside of the circle here, then that rotation, if that distance is exactly equal to this distance, so let's say that the radius here is 3 units, and this was now exactly 3, then the angle of rotation that I just created, that would be exactly 1 radian. Okay? So how do you convert? So how many radians are in a circle? Well, we just sort of did that, right? We said that if you go a full rotation, there are 2 pi, then the distance would be 2 pi times r, which is the radius. So in a full circle, there are 2 pi radii. So how many radians are in a circle? Well, in 360 degrees, you have 2 pi radians. So 2 pi radians is exactly 360 degrees. Let's divide by 2 here. So pi radians is then, not 45, dividing by 2 here is exactly 180 degrees. And this is what we're going to use to convert stuff. So if I have degrees, so clearly I have degrees here, 45, and I'm going to convert to radians, then I need to somehow use this 180 and this pi. So if you want to cancel the degrees, the 180 goes over here. And that means 2 pi goes over here. Pi goes over there. I have a hard time reading my 8 there. So That's the conversion unit that we want. Okay, and then so we're multiplying here, and if you cancel all the way out, 45 goes in exactly 4 times in 180, so that would be pi over 4 radians. Now usually when we include pi in the measurement, it's understood that it's radians. Okay, so how about 210 degrees? Well, we're going to use the same multiplication. So 180 goes here, pi goes over there, and 210 has a 30 in it, and so does 180. So 21 divided by 3 is 7. So 7 30s go into that, and 6 30s go into 180. So 210 degrees is 7 pi over 6 radians. So how do you convert from radians to degrees then? Well, basically the same way, except now you're going to use your ratio the other way around. So if you want to convert pi radians, then the radian unit needs to be in the bottom. So we need to cancel the pi radians with the pi. And then here we will get 180. And hopefully pi radians gives us 180 because we saw that a moment ago. So you do. So 1/3 pi radians, let's just write that as commonly written as pi over 3. So we're going to multiply that by 180 over pi this way so that the pi units cancel. So 180 divided by 3 is 60. So pi over 3 radians is 60 degrees. And then 2 radians, and so this one's on here because we often now, or often, once you do this a lot, people associate 2 pi with the circle, right? So 2 pi radians is exactly 360 degrees. But this literally says 2 radians. So 2 is a radian unit, so it would be 2 over 1 times, and that's a radian unit, so the pi goes over here. And then you get 180 over pi over here. And that would require us to get a calculator, because we can't simply cancel here. And if you did this on a calculator, you get about 114.6 degrees for 2 radians. Okay, another thing then that you need to keep in mind is that if the whole circle is 2 pi radians, right, and pi is about 3.14, then 6.28 radians is a full circle. So a full 360 degrees. Okay. What else do we have? There are certain angles that occur very frequently. So, and some of those come from special triangles, and a lot of them deal with 90 degrees. So here are some things that hopefully you'll learn pretty quickly. So 0 degrees is exactly 0 radians. That should make sense. If you go 30, it's actually pi over 6. 45 is pi over 4. 60 degrees is pi over 3. 90 degrees is pi over 2. 90 degrees would be pi over 2. And you can see them here. 180 was pi, 270, 3 pi over 2, and 360 is 2 pi. Okay, you will have to sort of, you don't have to memorize this, but hopefully the more that you do it, the more that you'll know these, and you'll get fairly good at converting. So the way that I have this memorized is that I look at 180, and then if I want to know what pi over 3 is, I go, well, how many 3's going into 180? 6. So that would be 60 degrees. And then pi over 6 would be the other way around. So if I have pi over 6 and I compare that to 1 over 80, how many 6's go into 180? Well, 3. So that's 30 degrees. And anything over 4, then I know deals with the 45 degrees. So anything with a 4, how many 45's go into 180? So that would be 4. But that means this is at 45 degrees. And it works sort of the same way if I gave you, for example, well, what if I said 5 pi over 6? Okay, so I'm thinking, well, how many 6's go into 180? 30. So this is 5 30's. So 5 30's would be 150 degrees. So if I look over here, 150, I better get 5 pi over 6, which I did. Okay. And then finally, the last part here is some calculator things. So degrees, radians, and stuff on your calculator. So if I type in the sine of 4, okay, in the calculator, and if I do the sine of 4 and I have it in degrees, I will get 0.07 as an answer. If I type in the sine of 4 and it's in radians, then I get a negative 0.76. So clearly I have completely different answers. Okay, they're not the same. They're not even the same sign. They don't even have, one's positive, one is negative. So, how do you know which one to use? Well, in general, if nothing is mentioned, you are supposed to be thinking about all these now in terms of radians. So if I say that an angle, theta, has a measurement of 3, then you are supposed to understand that that's radians. Now, I will definitely write 3 radians for a little while there. But if I clearly use the symbol pi, for example, if I say the angle is pi over 3, you are now supposed to understand that, you know what, that is definitely in radians because it uses pi as a symbol. And actually, how many times does 3 go into 180? 60, right? So that's 60 degrees, okay? All right, and I did want to show you then the last thing here, and that would be sort of why I get this over here. So here's a circle. If I can get a circle to show up somewhat. Okay, so why did I draw a circle? Well, because these both refer to a rotation, right? And hopefully you remember that the sine of an angle was defined as the y over r. So if I go sine of 4 degrees, and we're doing this in degrees, then hopefully you will agree with me that 4 degrees is very low, right? So if I'm looking at that, then the y value over here is very, very small relative to the hypotenuse. And so 4 degrees, the y value here is definitely positive, and it is small. So you get a very small number out of here, small relative to the hypotenuse. If I said the sine of 4 radians, well, then you have to keep in mind that radians is a completely different measurement. So we know that pi radians, for example, is over here. And the reason I say pi, because pi is 3.14. So 4 radians is going to be past that. So 4 radians, actually, if you did the math on it and converted it, it would be somewhere over here. Okay? So that is 4 radians. Well, if I compare that y value to the hypotenuse, we can see here that the y value is negative, and it's not near, I mean, it's definitely not as big as the hypotenuse, because then you'd be over here, but it's definitely way bigger than the one that's associated with 4 degrees. So this was 4 degrees, and this was 4 radians. So at least you can, hopefully you can see that you should definitely get a negative out of here. Okay? Thanks.